Assalamualaikum warahmatullahi wabarakatuh. Good morning everyone. Today I will present measurement. Everyone, you can see here table of contents consists of cover, purpose, theoretical basic, tools and material, procedures, observational data and discussion, conclusion and reference. The purpose of this practicum are to learn the method of measuring length, mass and time, to study the use of the theory of errors in measurement. Theoretical basic. The uncertainty of error due to levity, which is the limitation of the accuracy of each measuring instrument and the inability to read the measuring instrument. Then, relative uncertainty, namely uncertainty that has no units and is often expressed as a percent. The smaller the relative uncertainty, the greater the level of accuracy in the measurement process. The tools and materials that I use in this practicum are ruler, vernier calipers model, bottle cap, smartphone, manila paper, yarn, coin, eraser, stopwatch, buckle ball, and buttons. Everyone, you can see here there are procedures. Activity 1, vernier calipers model. Here, prepare the cardboard. Make a vernier calipers with a fixed 18 mm scale, divided into 20 vernier scale, to determine the accuracy of the calipers. Then, use a caliper to measure the outer diameter of the bottle cap, the inner diameter of the bottle cap, and the dip of the bottle cap. Collect the data in the table data. Here is a measurement picture of the dip of the bottle cap, inner diameter of the bottle cap, and then outer diameter of the bottle cap. Activity 2, measure the thickness of the smartphone. Here, use a caliper to measure the thickness of the smartphone, and then record and calculate measurement result. Here is a measurement picture. Activity 3, measure the length of the smartphone. Here, use a ruler to measure the length of the smartphone, and then record and calculate measurement result. Here is a measurement picture. Assessment 4, analyze mass of the ring, understand the statement, record the mass of the ring before and after the fall, and then analyze and conclude the research. Activity 5, measure mass using simple plan. Here, prepare 2 or more manila papers. Then, cut a sheet of manila paper into 10 equal pieces. Take one of these pieces and cut into 10 equal pieces. And then, take one small piece and cut into 10 equal pieces. Then, make the pieces of the paper as weights. Name one complete sheet of paper with the name mass unit, for example Q. Then, make for the balance model, use the weight Q to measure the buttons for clothes, coins, and the bottle cap. And then, record the result. Here is a measurement picture using bottle cap, coin, and buttons. Activity 6, measuring the period with a simple pendulum. Here, prepare the buckle ball, thread, and ruler. Then, measure the length of the rope and then cut the rope. Tie the rope with the buckle ball. Then, the thread is tied to support. Take repeat time measurement for 10 swings. Measure the time for 10 times swing and record the result of the observation table. Here is a measurement picture. Everyone, you can see here my observation table. Assessment 1, small scale value is 0.01 cm. inner diameter of the bottle cap is 3.09 cm. Outer diameter of the bottle cap is 2.91 cm. Tip of the bottle cap is 1.09 cm. Measuring result is X is xi plus minus delta x. Outer of the bottle cap is 3.09 plus minus 0.005. Relative uncertainty is delta x divided by x bar multiply 100%. Relative uncertainty is 0.005 divided by 3.09 multiply 100%. Relative uncertainty is 0.16%. Inner diameter of the bottle cap is 2.91 plus minus 0.005. Relative uncertainty is 0.17%. And the tip of the bottle cap is 1.09 plus minus 0.005. Relative uncertainty is 0.45%. And then everyone, you can see my observation table. Here assessment 2 small scale value is 0.01 cm. In the first experiment, the result is 0.76 cm. In the second experiment, the result is 0.77 cm. In the third experiment, the result is 0.79 cm. Measurement result, X is x bar plus minus delta x. The raw estimate is 0.77 plus minus 0.02. Relative uncertainty is 2.59%. The made estimate is 0.77 plus minus 0.01. Relative uncertainty is 1.29%. And the fine estimate 0.77 plus minus 0.016. Relative uncertainty is 2.07%. Everyone, you can see my observation data table. Here assessment 3, small scale value is 0.1 cm. In the first experiment, the result is 13.6 cm. In the second experiment, the result is 13.7 cm. In the third experiment, the result is 13.8 cm. Measurement result is x bar plus minus delta x. The raw estimate is 13.7 plus minus 0.1. Relative uncertainty is 0.72%. The made estimate is 13.7 plus minus 0.06. Relative uncertainty is 0.43%. And the fine estimate is 13.7 plus minus 0.1. Relative uncertainty is 0.72%. Assessment 4. Analyze most of the terrain. In laboratory activities, the mass measurement of ring was carried out, which yielded 5.7 plus minus 0.1 gram. After the ring falls and is found on the floor, it is weighed and the resulting mass is 5.4 plus minus 0.1 gram. When an object is translating, there are different kinetic energies of object, where the kinetic energy of object is determined by the object mass and object center mass velocity. Object will experience different object energies when they experience rotational motion. Two objects with the same mass and the same angular velocity may have different kinetic energies measuring up to 30 cm. And then everyone, you can see my observation table. Assessment 5. The mass of the smallest weight is 0.001 Q. Here, buttons. In the first experiment, the result is 36 Q. In the second experiment, the result is 40 Q. In the third experiment, the result is 42 Q. X is 39.3 plus minus 3.05. Relative uncertainty is 7.76%. And then coin. In the first experiment, the result is 470 Q. In the second experiment, the result is 475 Q. In the third experiment, the result is 485 Q. X is 476.6 plus minus 7.63. Relative uncertainty is 1.6%. And then bottle cap. In the first experiment, the result is 200 Q. In the second experiment, the result is 205 Q. In the third experiment, the result is 215 Q. X is 206.6 plus minus 7.63. Relative uncertainty is 3.69%. And then everyone, you can see my observation table. Assessment 6. Here I use the length of the rope, namely 60 cm, with the angle that is 10 degrees. The number of the swings I can use is 10. In the first experiment, I get time is 12.30, with period is number divided by the number of swings. Then I get period is 1.13. In the second experiment, I get time is 12. Period is 1.2. In the third experiment, I get time is 12.05. Period is 1.205. Measurement result, period is 1.17 plus minus 0.042. Relative uncertainty is 3.58%. Everyone, from this practicum, I can draw the conclusion is, from the measurement experiment, it can be seen that measuring instrument consisting of rulers, calipers, and mass measuring instrument, namely balance. In the measurement practicum, use a caliper to measure the inner diameter, outer diameter, and the depth of the object, and also the thickness of an object. A ruler is used to measure the length of an object, and a scale is used to measure the mass of the object. The caliper has a scale value of 0.1 mm or 0.001 cm, and the ruler has a scale value of 1 mm or 0.1 cm. The theory of error. In the theory that may be wrong or correct due to errors in the equipment, incorrect calibration, or personal errors in the observer. Reference: Azwas S. 1997, Sikap Manusia, Teori dan Pengukurannya, edisi kedua, Penerbit Pelajar, Yogyakarta. And then Hariday Resnik, 2010, Fisika, edisi 7, Jilid 1, Erlangga, Jakarta. I think all for my presentation. If there is any mistakes, I do apologize. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.